Good afternoon, ladies and gentlemen. It is Thursday, October 23rd. We're going to be wrapping up Chapter 4 with Section 4 or 5. We just kind of did some basic logarithmic stuff in the last section yesterday, and today we're going to talk about a little bit more of the properties of logarithms. All right, so this first page right here, this first slide, I guess you could say, these are the kind of the four basic properties we're going to look at today with some additional pieces after this. All right, now the easiest way for me to explain these is if it's in a logarithmic form is to convert it to exponential, or if it's in exponential form, convert it back to logarithmic form. All right, so this first one's in logarithmic form, so what I'll do is convert it to exponential just to make my points. Anytime you have the log base a of 1, it's going to equal 0, and this is why. If you go back to what we were talking about when we first started talking about logarithms, convert it to exponential, it's a raised to the 0 equals 1. So if I had a raised to the 0, anything to the 0th power is always going to be 1. So that's why you have log base a of 1. It's always going to equal 0. All right. Second one, same thing. If I take and convert it from logarithmic to exponential, a to the first equals a. So a to the first equals a. Remember, anything to the first power is always going to equal itself. It could be 7 to the first, that equals 7. 21 to the first, that equals 21. X to the first, that's going to equal x. So again, converting it from logarithmic to exponential form is just the easiest way to explain these. All right, the next one, it says a raised to the log base a of m equals m. All right, now in this case, it's in exponential form, so what I want to do is convert it to a logarithmic. So it's going to be log base a of m equals log base a of m. So again, log base a of m is going to equal log base a of m. All right, so that's just explaining that one. This next one, guys, it's in logarithmic form, so I want you convert it to exponential. So it's going to be a raised to the r equals a to the r. So a raised to the r equals a to the r. All right, so typically in most of these, what you're doing, anytime you're trying to solve or simplify, if it's in logarithmic form, the easiest way to convert it or to solve it is to convert it to exponential form, and then vice versa. All right, so let's take a look at a couple examples down here. All right, so this first one is log base 3 of 3 raised to the 71st power. All right, so to me, the easiest way to do this is to set this equal to x, or whatever your favorite variable is. You can choose your favorite one. All right, set it equal to x, and then go through and solve it. All right, so it's in logarithmic form. So let's take it, let's convert it to exponential. So it's going to be 3 raised to the x power equals 3 to the 71st power. So 3 raised to x equals 3 to the 71st. Now, if you remember back to our exponential section, if we have the same base, so I've got a base of 3, if we have the same base, then I can set my exponents equal to each other and solve. So here, I set my exponents equal, I get x equals 71. All right, so this is going back to this property right here, this last property right here. So log base a of a to the r is just going to be equal to whatever my r value is. In this case, my r value is 71. It's equal to 71. All right, so instead of trying to memorize some of these properties, it might be easier just to solve it. Convert it to an exponential and solve. Or convert it to a logarithm if it's an exponential. All right, so second example right down here. Once again, I'm going to set that equal to x, or again, you can choose your favorite variable. Whatever floats your boat. All right, so same thing. So I've got 5 raised to the log base 5 of 10. So once again, I'm going to take this. It's in exponential. I'm going to convert it to a logarithm. So 5 raised to the x. I'm sorry, and now I'm converting it to an exponential. So it's going to be log base 5 of x equals log base 5 of 10. So it's log base 5 of x equals log base 5 of 10. So right here, I've got the same base. It's pretty easy to see that x has to equal 10. So I've got the same base, log base 5. Those are equal. So x has to equal 10. So again, sometimes it's just easier, instead of trying to go through and memorize properties, just easier just to set things equal. they're in logarithmic form, convert them to exponential. If they're in exponential form, convert them to logarithmic. All right? So there's some of the basic ones we're looking at today. The other ones, we're going to actually work on expanding and condensing logarithmic equations or logarithmic functions, or logarithmic expressions is probably the best way to say it. All right, so first one we have here, and I'm just going to cover up these other ones so we don't get too distracted, even though you've got yours in front of you already. All right, if we have log base A of two numbers being multiplied, all right, this is what we would call condensed form. All right, everything is in terms of a single logarithm. All right, but if I have two numbers being multiplied, all right, then what I can do is I can expand that, is how we usually say it. We can expand that into two separate logarithms being added together. All right, so we have multiplication that goes with addition. All right, so if I had, just as an example here, if I had log base A of, we'll just say 10x. All right, well, that's 10 times x. So I can rewrite that as log base A of 10, the first part, plus log base A of x. So I took it from a single logarithm, log base A of 10x, and I expanded it to the sum of two logarithms, with that same base. So again, multiplication goes with addition. All right, so the next one we're going to look at is division, which goes with subtraction. All right, log of a quotient equals the difference of the logs. So once again, I've got a single logarithm here. All right, I'm dividing two values, so m divided by n. All right, so when I'm dividing two of those, I can expand it into two logarithms being subtracted from each other. All right, so if I use the same example, so if I have log base A of 10 divided by x, so I've got division here, we're going to expand that because notice I have a single logarithm. I'm going to expand that to the log base A of 10 minus log base A of x. The piece that's in the numerator always comes first. We're going to subtract off the piece that's in the denominator. All right, so I expanded it from a single logarithm to multiple logarithms. Because it's division, I'm going to use subtraction to expand it. All right? And the last part we're going to look at is log of a power equals the product of the power and the log. All that means is you're going to take whatever is your exponent here, whatever that exponent is, when you expand it, that exponent moves to the front of your logarithm. So notice, after I've expanded it, instead of being up here, now it's down in front. All right, so that logarithm has moved from my exponent to the front. So it's the product, which means multiplication. So anytime you see an exponent, you can move that piece to the very front of that logarithm. All right, so those are the three additional properties we're going to look at here. So now we're just going to go through and do some practice expanding and then condensing. All right, that's really what the remainder of this period is going to be. All right, so let's look at the first one, or I guess example number 3. All right, so right here we are going to, didn't say. All right, we're actually going to condense this. All right, so notice I've got addition. All right, if you go back to that previous slide, the piece that goes with addition is multiplication. So right now it's in expanded form. So I have multiple logs. So I want to condense this down into a single logarithm. All right. So what that means is I've got log base 8 of 2 plus log base 8 of 4. So again, it goes with multiplication. So this is going to be, if I condense this, log base 8 of 2 times 4. Not a multiplication. That's not subtraction, it's multiplication. All right. Well, 2 times 4 is 8. So this is going to be log base 8 of 8. All right. Now, don't leave it like this because it's not completely simplified. All right. Anytime you have the log and the base is the same as what you're taking the log of, it's always going to equal 1. And if you're not sure, do what we did before. We're going to set that equal to x and solve. All right. So it's in exponential, or it's in logarithmic. I'm going to convert it to exponential. So it's 8 raised to the x equals 8. So 8 raised to the x equals 8. I'm going to call that 8 to the first. Once again, I've got the same base. So we'll set my exponents equal to each other. So x equals 1. Alright, so let's look at this next one here. Alright, so once again, I've got everything in expanded form in multiple logarithms. So what I want to do is condense this into a single logarithm. Now, if you notice, we've got subtraction here. If you look back at that previous slide, division goes with subtraction. Alright, so if we're going to condense this, alright, remember division goes with subtraction. Alright, so we are going to condense this to a single logarithm using division. So it's going to be the log base 6 of 18 divided by 3. Remember, the piece that comes first is what's going to go in the numerator. Now, we've got log base 6. 18 divided by 3 is 6. So it's log base 6 of 6, right, which we saw right up here previous. Anytime your base is the same as what you're taking the log of, it's just going to be 1. So log base 6 of 6 is just equal to 1. Cool? Cool. Alright, so now let's take each one and we are going to expand them. So these are all written in a single logarithm, or as a single logarithm. We're going to expand them. Alright, so we're going to take it step by step. Alright, so this first one. Alright, I don't have anything being added or multiplied, divided, added, subtracted. However, I do have an exponent up top. Alright, that very last rule that we were looking at was if we have an exponent up top, we can take that exponent and move it out to the front and be multiplied by that log. Alright, so this is going to look like the exponent moving out front. So 3 times log base 2 of z. Alright, and since again I want multiplying or dividing by anything, I'm not going to have multiple logs here. So that's my answer. Alright, so let's look at the next one. Alright, so in this case, I'm actually dividing, and I've got an exponent. So let's go ahead and work on expanding that first. Alright, so remember, division goes with subtraction. So that's the first thing I'm going to do. So we're going to have the log base 2 of a, and the piece of the numerator goes first, minus log base 2 of b squared. Remember, division goes with subtraction. The piece in the numerator is going to come first. Alright, now I'm almost done. If you notice, though, I've got an exponent right here. So once again, like we said before, that exponent can move right up front. Alright, so that's going to be log base 2 of a minus, now we move the exponent up front, it'll be 2 times log base 2 of b. And there is my expanded form. Easy breezy. Alright, cool. Alright, so let's try a few more. Alright, now some of these, as many of you are used to with math, they start off a little bit easier, and of course they're going to get a little bit more difficult. So, that's okay though, we'll work through it step by step. Alright, so this first one. Now we've got x times the square root of x squared plus 1. So the first thing we've got here is a multiplication. Alright, so it's written right now as a single logarithm, so we want to expand it to multiple logarithms. So the first thing we're going to work with is our multiplication. So if you remember, multiplication goes with addition. Alright, so to expand this is going to be log base a of x plus log base a, the square root of x squared plus 1. Alright, so that's the first thing we've got. Now, if I look at this first logarithm right over here, there's nothing else I can do. Nothing's being added or subtracted. I don't have any exponents there, so there's nothing else that I can do right now. Alright, so I'm not going to deal with that one at all. Alright, so however, let's look at this one. This one we do have something else involved, and it's not something that might be obvious to you right at first. Alright, but what we have here is the square root. Now, it doesn't look like it's raised to any power. Alright, but just to kind of review with you guys or to remind you of something. Alright, if I were to take the square root of 81, that's going to be 9. Alright, instead of taking the square root of something, the other way you can do it is you can raise it to the 1/2 power. So anytime you take the square root of something, that's the same thing as raising it to the 1/2 power. Or if you have the cubed root of something, say I have the cubed root of 8, which is 2, that's the same thing as taking 8 and raising it to the 1/3 power, which would also be 2. All right, so the square root of something is the same thing as raising it to the 1/2 power, which if you notice over here, I've got the square root. So what I'm going to do is instead of writing it as a square root, I'm going to write it as raising x squared plus 1 to the 1/2 power. All right, so we have log base a of x plus log base a of x squared plus 1 raised to the 1/2 power. All right, so that's what we've got. So there's one other thing that I can do here, and that is, in fact, this exponent. So again, I've got an exponent, so I can take that exponent and I can move it to the front. All right, so the last part of this is log base a of x plus, now I'm going to move my exponent to the front, 1/2 times log base a of x squared plus 1. All right. Now, since I'm expanding it, I can only expand multiplication to addition. So this piece right here that has addition, I can't do anything else with it here. I'm not going to expand it to multiplication. That would only be condensing it. So right here, this is my final answer. Cool. All right, so this next one is probably one of the most involved ones that you will see. All right, it's in a single logarithm form. It's completely condensed right now. We want to expand it. So it's going to take a little bit. So first we've got division. So I've got a division here, this divided by this. That's the first thing we're going to do. So let's just take it one thing at a time, guys. It looks like a lot, but if you just break it down and take it one step at a time, it's much easier. So I've got the square root of x cubed plus 1. All right, so remember, with division comes subtraction. All right, so I've got log base a of x cubed times x plus 1 to the 4th. All right, so it's log base a of x cubed plus 1 minus that right there. Now, once again, all right, let's just do one piece at a time. So what I'm going to do is I'm going to work with this piece right here. I'm not going to work with the rest of it yet. I'll work with this piece here. So once again, I've got the square root, so I want to raise that to the 1/2 power. So log base a of x cubed plus 1, I'm going to raise it to the 1/2 power, minus. All right, so that piece goes, I'm just going to highlight in the same color, that way you guys know. All right, so now let's work over here. All right, first thing is I've got multiplication. So the way we expand multiplication is through addition. All right, so we've got log base a of x cubed plus log base a of x plus 1 to the 4th. All right, so all that is with that. All right, so just kind of keep things in order for us. All right, so right here on this green side, the only thing else that I can do here is I can take this exponent and I can move it out front. So I'm going to take that 1/2 and I'm going to move it right out front. So now I'm just going to write 1/2 times log base a of x cubed plus 1. There is absolutely nothing else that I can do here. All right, there's nothing else I can do with that. I can't expand x cubed plus 1 anymore, so I'm done with that part. All right, minus. All right, now, this I've got a couple things going on. First thing, got an exponent. We're going to take that and move it in front of the logarithm. Same thing here. This 4, I'm going to move it and put it in front of that logarithm. So it's going to be 3. Let me go back to, so it's going to be 3 times log base a of x plus 4 times log base a of x plus 1. And the reason that I've been putting these in parentheses from the beginning is this negative is affecting everything here. Alright, so now that we've expanded everything, now I need to make sure I distribute that negative through. So it's going to go here. So this last step right here is what? 1/2 times log base a of x cubed plus 1 minus, distribute the negative, so negative times positive is negative, so minus 3 times log base a of x. And then the same thing here. Distribute it there and distribute it there. Alright, so negative times positive is going to be negative, or minus 4 log base a of x plus 1. And like before, guys, you have to forgive my handwriting. I'm using a mouse again. So that is going to be your expanded form. Now, it seems, some of it can seem kind of difficult, but I promise you, if you take it step by step by step, even if you want to use a highlighter to help you, all right, to make sure you keep things in line, that's fine too. All right, whatever helps you. All right. So, but that's going to be taking it from a single logarithm and expanding it to multiple logarithms. All right. Now, let's kind of look at it the other way. So now they're giving it to us in expanded form. We want to condense it to a single logarithm. All right. So first of all, kind of want to work backwards here. So before we expanded the multiplication and division, everything like that first, here we're going to work with any exponents and work backwards. So I've got a number out front, and if you remember, if we ever had an exponent, we moved it out front, so now we're going to go backwards. If I have a number out front, I'm going to move it to the exponent. All right, so I'm going to take that, and I'm going to put it right there. And the same thing with this 4. I'm going to take that 4, and I'm going to move it up to that exponent. So I'm going to move it right up there. All right, so this first part, I'm going to rewrite this as log base 5 of u to the third plus log base 5 of v to the fourth. So notice I took both of those exponents, or both those numbers out front, and moved them to be the exponents. All right, so the last piece here, and then we're almost done, is to take, remember, to condense addition. Addition goes with multiplication. So to condense addition, we're going to multiply. So I've got log base 5. Notice take the same base. It's all base 5. Log base 5 of u cubed times v to the fourth. And because those don't have the same base, I am done. So it's log base 5 of u cubed times v to the fourth. Cool. All right, so let's look at this next one here. So once again, same thing. I'm going to look to see if I have any numbers out front first so I can move those to exponentials, then see if I've got addition, subtraction, see if I can condense that using multiplication, division, etc. All right, so first thing, all right, I don't have any numbers out front of this first part, so let's look down the next one. I do have a number out front here. I've got a 5. So remember, number out front becomes an exponent. All right, so if I've got that 5, it's going to become the exponent out here. So let's just write that first part out first. So I've got log base 4, put the 4 there, of x squared minus 1, minus, again, that 5 moves to the exponent, so it's no longer out front, so minus log base 4 of x plus 1 to the fifth. So again, that 5 now becomes my exponent. All right, so no other numbers out front, so let's see if we can't condense subtraction. Now, if you remember, addition goes with multiplication, division goes with subtraction. So to condense this, I'm going to do division. Remember, the piece that comes first is going to go in the numerator. So I'm going to have log base 4 of, so x squared minus 1 is going to go in the numerator. And then x plus 1 to the fifth is going to go in my denominator. Now, this actually can simplify a little bit more, all right, if we wanted to go ahead and simplify it. All right, log base 4 of x squared minus 1. Now, what I'm going to do is I'm going to factor this, and you guys will see what's going to happen. So x squared minus 1 factors into x plus 1 and x minus 1. Correct? Correct. All right, now, if you guys look at the denominator, it's x plus 1 to the fifth power. Now, that means I've got 5 x plus 1s. So if I wanted to write out x plus 1 times x plus 1 times x plus 1 times x, I could write it out 5 times. I'm not going to, but you could. That's what it means. All right, but if you notice up top, I've got an x plus 1. So this x plus 1 will cancel with one of these denominator x plus 1s. So instead of having 5, if that x plus 1 in the numerator cancels with one of them, I'm left with 4 in my denominator. So what I'm going to be left with is actually log base 4 of x minus 1 over, if that x plus 1 in the numerator cancels with one of those x plus 1s in the denominator, I'm now left with 4 of them. So it'll be x plus 1 to the 4th. Math is a beautiful thing. I know you guys are loving this right now. So, cool. All right, so same thing. We're just going to do a couple more of these practice ones. They are going to get a little more difficult. So just forewarning you, for example, right here. All right. All right, so let's look at this one now. This one's probably a little bit more involved than the other problems we were just trying. All right, but that's okay. Let's take it one piece at a time. All right, so the first thing we see here, guys, is I've got a number out front. All right, so that's going to have to come up here and be an exponent. All right, so it's going to come right up there. All right, so first thing let's do, log base 2 of the square root of 3x minus 2 raised to the 8th power. We're actually going to come back and simplify that a little more in just a second. Now, right here, if you notice, I've still got a division problem. I've got 4 over x. So the easiest thing actually here, before I start condensing everything, is to actually expand this just a little bit more to make it look a little bit nicer. All right, so remember, division goes with subtraction. So I'm just going to expand that a little bit before I start going through and condensing. So it's log base 2 of 4 minus log base 2 of x. You'll see why we do that in a few minutes. And then I've got my plus log base 2 of 4. All right, so again, I moved my exponent up here, and I just expanded this 4 over x a little bit. All right, so now what's going to happen is this negative is going to distribute to both pieces in there. So it'll be negative, and then negative times negative will be a positive. Now, the other thing here, if you remember back to a couple problems earlier, when we said the square root of something is the same as raising it to the 1/2 power. All right, so right over here, I'm going to take this. I'm going to show you what that's going to look like over here. All right, so to the right-hand side, just kind of a little sidebar. All right, so if I've got the square root of 3x minus 2, and that's raised to the 8th power. All right, remember, that's the same thing as saying, instead of taking the square root, that's the same thing as raising it to the 1/2 power. All right, and I've still got it all raised to the 8th. So this is the same thing. So taking the square root of 3x minus 2 is the same as taking 3x minus 2 and raising it to the 1/2. Now, I've still got it raised to the 8th power. And if you guys remember back when we were first looking at the powers of x, or the properties of exponents, anytime you have a power raised to a power, you multiply. So half of 8 is 4. So what this is going to simplify to be is 3x minus 2 raised to the 4th power. So the square root of 3x minus 2, all that raised to the 8th, simplifies to be 3x minus 2 to the 4th power. All right, so I'm actually going to write that over here. So log base 2 of 3x minus 2 raised to the 4th power. All right, so there's that. All right, now I took my negative and I distributed it here. So let's distribute it through. So I got minus log base 2 of 4. And also I've got negative times a negative, so that'll be a positive. So plus log base 2 of x, and then plus log base 2 of 4. Now, because I expanded that, it makes it look a little bit prettier. And if you notice, I've got negative log base 2 of 4 and positive log base 2 of 4. So those are actually going to cancel each other out. All right, so I'm left with log base 2 of 3x minus 2 to the 4th plus log base 2 of x. So how do we condense addition? Well, addition goes with multiplication, so I'm actually going to multiply those, and that's a 4. I'll make sure that. So addition goes with multiplication, so the last step here is going to be log base 2 of x times 3x minus 2 to the 4th. So we'll put these in kind of brackets just to make sure it's log base 2 of all of that. And there is your answer. All right, so that one's probably one of the more difficult ones that you guys will see because it's a little involved. You got a lot of different things going on. All right, but just for a little bit more practice, I want you guys to take a quick second and try this last one here. All right, and Ms. Miller, if I start talking and they need extra time, just pause that and let them kind of finish up. All right, so let's look at this last one here. And again, if you guys need a couple more seconds, take a couple more seconds and pause this. Please remember, guys, that the best way you get better at this is to do it on your own first and then to check your results. All right, so first thing here, check to see if we got any numbers out front. I do. I've got 1 there, so that's going to become my exponent. I've also got 1 here, so that's also going to become my exponent. So I'm going to put a number out here and out here. All right, so first thing, let's go and rewrite it. So log base A of, I've got 5x cubed. Now again, this 2 is going to now become the exponent out here, so that becomes a 2 minus log base A of 2x plus 3. So same thing, this 1/2 is going to become the exponent right up here, so that's going to become 1/2. All right, so again, the 2 exponents are now my 2 and my 1/2. Those got moved from the front to become exponents. All right, so now let's take it next step. All right, so let's condense this a little bit further. So I have 5x cubed squared. So that means that squared, boom, means I got 2 of them. So I can actually distribute that here. So it's log base A of 5 squared is 25. And remember, a power raised to a power means I multiply, so 3 times 2 is 6. This is going to be 25x to the 6th minus. Now, if you guys remember what we've been doing, we've been taking square roots and turning them into powers or exponents. Remember, when you take the square root of something, it's the same thing as raising it to the 1/2 power. We can do the same thing and just work backwards. Raising something to the 1/2 power is the same thing as taking the square root. All right, so I just converted that 1/2 power to a square root. Same thing. All right, so now I've got subtraction. So what goes with subtraction? That's division. All right, so it's going to be log base A of 25x to the 6th. Remember, the piece that comes first is in your numerator, divided by square root of 2x plus 3. And that cannot be simplified anymore, so that do be your final answer, yo. So that one wasn't quite as difficult as the previous one, but still pretty involved. All right, now your homework for tonight, because this isn't finishing 4.5. We're going to finish that up tomorrow, actually. So your homework tonight is this homework assignment. All right, and please remember, guys, that the odd problems are on the website, or are actually on the book website. If you go in the bottom right corner, textbook solution manual, you guys can find all the odd problems worked out there. And the even ones, just do your best with, and Miss Miller can tell you guys the answers of those when you guys come in tomorrow. All right, but tomorrow we'll finish up 4.5. It's Friday. You guys will have your test over 4.1 to 4.5 next week. So just please, please, please make sure you are practicing and you are studying and you're getting as much help as you possibly need. But I hope you guys have a wonderful day. We will be back tomorrow to finish up 4.5. Talk to you guys later.